This is part B of problem 1 of exam 2 of spring 2022. We're told that we want a differential equation to calculate CA as a function of time and the boundary conditions for this stirred tank system. The reaction or the system of reactions is the same as it was in part A. A goes to A star reversibly, A star goes to B irreversibly. So in a stirred tank, our standard control volume is the whole tank, and everything is assumed to be well stirred or homogeneous within that tank. Since we want CA, a differential equation in terms of CA, so let's do our balance. So our balance on A, input minus output plus generation minus consumption equals accumulation. So the input, the rate of input of A is going to refer to the flow in your input stream. So it's going to be FCA in times delta T. The output, we're told that the volume isn't changing. See, it's constant at V, so the output has to also be F. So the output of A is going to be minus FCA. That's not the same as CA in, because it's the concentration of A in the tank itself. That's the output. So the generation of A is going to be plus K inverse CA star times the volume times delta T. The consumption is K1 CA times V delta T. And the accumulation is going to be CAV at T plus delta T minus CAV at T. And so I need to turn this into a differential equation. So what I'm going to do is divide through by delta T and then take the limit as delta T goes to 0. I'm also going to divide by V. So I'm going to say limit as delta T goes to 0, CA at T plus delta T minus CA at T divided by delta T. This is going to be dCA dt, and that's going to equal FCA in minus FCA over V plus K negative 1 CA star minus K1 CA. So this is, I'm going to box this, call it equation 1. Notice that it is insufficient to solve for CA as a function of T because it involves CA, and CA is not constant. So we now need to do a balance, CA star, and CA star is not constant. Let's do a balance on A star. And that's going to look very similar. So the input is going to be 0, because there's no A star in the input. The output is going to be FCA star delta T. The generation of A is going to be plus K1 CA V delta T. The consumption is going to be minus K negative 1 CA star V delta T minus K2 CA star V delta T, and accumulation is going to be CA star V at T plus delta T minus Ca star V at T. So we divide through by delta T, take the limit as delta T goes to 0, and what we ought to get from that is dCA dt equals minus F over V Ca star plus K1 Ca minus K negative 1 Ca star minus K2 Ca star, and this should be sufficient. Notice that only Ca and Ca star appear in these two differential equations. So they should be sufficient to solve for our object here, which is Ca. Notice the question does not actually ask us to calculate Cb or set up a differential equation for Cb, so that is not necessary. And we do need two boundary conditions. And the boundary conditions are Ca at T equals 0 because we said the tank only contains solvent and no solute. Both of these terms are 0 at the initial condition.